let's look at another rain umbrella problem. So what is the problem over here? There is a person, okay, and this person is walking towards right direction. The person is walking towards the right direction with a speed of 5 km/h, okay, and he finds out that the rain is falling vertically downwards. So the rain is falling vertically downwards like this. Okay, this is with respect to the person. Okay, this is not with respect to the ground. Okay, so with respect to person, the rain appears to fall downwards vertically with a speed of 12 km/h. Okay, so this is the speed 12 km/h of a rain. So the question asked is, what is the actual speed of the rain with respect to the ground and what is its direction? Okay, so that is what we have to find out. So let's see how to do this problem, but first let's name all the quantities which are given to us. So you already know that how do you write the velocities, relative velocities. So if I have to write the velocity of person, let me erase this. If I want to write the velocity of the person with respect to ground, then I will write it like this. This is P, the velocity of person with respect to ground. Okay, so velocity of person with respect to ground is 5 km/h in right direction. So I will keep it as I cap. So right direction I will take as the positive axis, and there is a downward speed of rain. Okay, so the downward speed of the rain is 12 km/h. So now this speed is given with respect to, this velocity is given with respect to the person. So I will write velocity of rain with respect to person. So this is 12 km/h. So I will denote it as J cap, but I will take it as minus because it is downwards. Okay, so downward axis is negative y. Okay, so this is minus 12 km/h. So now what is the question? The question is that what is the rain speed with respect to ground? So this is the question. Okay, now we already know, we have seen this formula that if you want to find out the velocity of rain with respect to ground, I can write it as velocity of rain with respect to that person minus velocity of the person with respect to ground. So I can split this like this, V bar Rp minus V bar Pg. Okay, so we can do that. So this is the equation for us. But now let's visualize the vectors over here. Okay, so for that we need a reference frame. So let me draw a reference frame over here. This is my origin. Okay, and what vectors we have over here? We have a first vector which is the velocity of the person towards right direction. So let's say this is our vector where person is moving towards right direction, velocity of person with respect to ground. So this is not Rp, it should be Pg, right? It will not be Rp, it will be Pg, velocity of person with respect to ground. Then let me use yellow color for denoting the velocity of the rain which is falling vertically downwards. So this is vertically downwards rain and its velocity is 12 km/h. So this is velocity of rain with respect to person. For person it is appearing that it is falling vertically downwards, right? Yes, so this is known now. So now we have to find velocity of rain with respect to ground. So velocity of rain with respect to ground. So we can use this formula. So here I can see that VRG is VRP minus VPG. Okay, so if I see these two vectors, I can see VRP like this. So can I just translate this vector downwards like this? So the answer is yes, you can always translate the vector. It doesn't make any change in that. The meaning of the vector is same. But V bar Pg is here towards right. If I want to write minus V bar Pg, then it will be towards left. So I will draw the V bar Pg vector like this. So this is minus V bar Pg vector. Now you can see that I can see this equation in this way. So this can be written as VRP bar plus minus of V bar PG. Okay, so that means if I add these two vectors, V bar RP and minus of V bar PG, these two vectors if I add, then I will get the velocity of rain with respect to ground. So the velocity of rain with respect to ground will be somewhat like this. Okay, this is the resultant of these two vectors. Now to find out the resultant of the two vectors when they are making angle of 90 degree with each other, then you will also directly use the Pythagoras theorem. So this is VRG. So the magnitude will be VRG is equal to square root of VRP square plus VPG square. So what is the answer? Square root of RP. The rain's velocity with person is 12 square plus velocity of person with ground is 5 square. So if you solve this, you will get 13 km per hour. So this is the velocity of the rain with respect to ground. So this is the magnitude, by the way. Okay, this is the magnitude. Now what we have to find? We have to find out the direction also. So let's find the direction with respect to the vertical. So this angle we have to find out, theta. Okay, so now to find out theta, I can see that if I translate this vector again downwards like this, I will again get this same vector minus V bar PG, and here this is this vector. So in this triangle, let's say this is A point, this is B point. In triangle OAB, I can say that tan theta is opposite side, that is the magnitude of V bar PG divided by adjacent side V bar RP's magnitude. So what is V bar PG? V bar PG is 5 and divided by RP. What is RP? 12. Okay, so this kilometer per hour will get cancelled and you will get tan theta as 5 by 12, and theta is tan inverse of 5 by 12. So the rain is falling at an angle of tan inverse of pi by 12 with respect to the vertical. Okay, so this is the angle with respect to vertical for the rain. So the rain is actually falling like this. Rain is falling like this. Okay, and when the person walks, it gets turned and by a certain angle, and it appears for that person that it is falling on its head vertically.